Hello, my friends. We're going to get started looking at the 2.3 That Quiz assignment, and we're really going to be differentiating between linear and exponential in this assignment. So you're going to find your name in the drop down and type in that password, which is always GCVS. If you don't see your name for some reason, please send me a message and I'll make sure to add you, and then hit OK. So when we're looking at these numbers, we want to see, is there an added value that it's increasing by, or is it being multiplied? That's going to be the big difference between linear and exponential. So to go from 2 to 7, we add 5. There's no multiplier that goes from 2 to 7. That's like clean. 7 plus 5 gets us 12. 12 plus 5 gets us 17, and 17 plus 5 is 22. So this is an example of linear. It's going up by an added amount each time. Here's our next one. We have 3, 6, 12, 24, and 48. So we can see these numbers are getting bigger, faster. That's a clue that it might be exponential. So we could think about multiplication. So if we multiply by 2, 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. And 24 times 2 is 48. This is an example of exponential. They're getting bigger. The values are getting bigger quicker because they're being multiplied instead of adding. That's at an exponential rate. Go ahead and hit OK. All right, we have 1, 2, 4, 7, and 11. If we think about addition, we're adding 1, and then we're adding 2, then we're adding 3, and then we're adding 4. That is not linear because we're adding a different amount each time. So it can't be linear. If we think about multiplication, 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8, and we have a 7 here. So this is actually not linear and not exponential. That does not follow a pattern of addition or of multiplication. So go ahead and hit neither and hit OK. Here's our next one. 1, 3, 9, 27, 81. Again, we see those numbers going up pretty fast. So that tells us that it's probably exponential if it is one of the two. So we're going to think about multiplication. 1 times 3 gets us 3. And that seems to work for the next one. 3 times 3 is 9. 9 times 3 is 27. And 27 times 3 is 81. So this is in fact exponential. So you're going to plug in exponential and hit OK. This next one, 33, 44, 55, this is fun, 66 and 77. So they're not like jumping high really fast. They're kind of going at a steady rate. So let's look at what the addition could be. They're getting larger. 33 plus 11 gets us 44. 44 plus 11 gets us 55. 55 plus 11 is 66. And this plus 11 gets us 77. So this is increasing at a linear rate. So you can hit linear and hit OK. These numbers, we have 75, 50, 25, 0, negative 25. We can see they're going down, and they're going down pretty consistently at the same rate. So what we have here is we're going to think about subtraction. So we're going to subtract 25 from 75 to get 50. 50 minus 25 is 25. 25 minus 25 is 0. And 0 minus 25 is negative 25. So this is linear. It's just going down. So this is decreasing linear. That would be a negative slope. Beautiful. Then we have 64 starting pretty big, and then it gets cut in half again, cut in half again, and cut in half again to get 4. So these values are dividing by 2, which we can also think about as multiplying by a half. 64 divided by 2 is 32. 32 times a half is 16. And then we get to 8, and then we get to 4. So this is going to be exponential decay because the multiplier is less than 1. So it is exponential, but it's just decay. Beautiful. Alrighty, for this one, the numbers are pretty steady, right? -7, -9. They're staying pretty close together. And we'll notice that these values are actually going down by 2 each time. They're staying negative, and they're getting 2 further. -9 minus 2 is -11. -11 minus 2 is -13. -13 minus 2 is -15. So this is, in fact, linear. Our numbers here, 1, 2, 4, 8, 16, 32, jumping pretty quickly. So we may think about multiplication, see if that works. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16, and 16 times 2 is 32. So this is exponential with a multiplier of 2. Okay. Then we have 60, 58, 54, 48, and 40. We'll think, well, first of all, we're going down by 2, and then we're going down by 4, and then we're going down by 6, and then by 8. So we're going down by a bigger amount each time. So it's definitely not linear, because if it was linear, it would have to be going by the same amount each time. So this is going to be an example of neither. It is not at a linear or an exponential rate here. All right, we've got 5 more to look at together. A library has 8,000 books, and it's adding 500 books each year. So we're starting with 8,000 and then 500 each year. That's linear because, again, it's going to be plus 500 one year, plus 500 the next year, plus 500 the next year. We're keeping that rate the same. A bank account starts with $10 every month, and then it is tripled. So this is a multiplier of 3. So if it starts with 10 and then it's tripled, then we'll be at 30. And then it's tripled again, so then we're at 90. And then it's tripled again, so we're at 270. So we see it getting big quicker. That's because it's growing at an exponential rate. At the start of a carnival, you have 50 ride tickets. Each time you ride the roller coaster, you have to pay 6 tickets. So if we're starting with 50, you ride the roller coaster once, that costs 6 tickets, so then you're at 44. You ride it again, then you're at 38. You ride it again, then you're at 32, right? Each time we're going down by 6 for that roller coaster price of 6 tickets. So this is linear. There are 20,000 owls in the world. Every decade, the number of owls is halved. This is going to be, so again, this is going to be decay, and it's being halved. So if we start with 20,000, the next decade we have 10,000. The next decade we have 5,000. Then 2,500, and so forth. Halving it or multiplying by 1/2 is exponential, and it's exponential decay. And I believe our last one here says Julie gets a prepaid cell phone. Initially, she has a $40 balance, and then each minute is 15 cents. This literally used to be how my cell phone plan would work out. This is linear. it's always 15 cents per minute, so it's going down by 15 cents each minute that you're on the phone. So it's going to be a linear function. Yay! So that is the end of the That quiz. Make sure you're finishing that, and when you're all complete, make sure you're also turning it into Schoology, okay? If you have any questions with that or you need anything from me, just let me know. Nice job, y'all. Keep working hard. You got this.